Welcome to the Serbu Motor channel. This channel provides easy-to-understand explanations of car mechanisms. We feel refreshed and energized when we breathe in fresh air in forests or grasslands. Surely, the same must apply to automobile engines. However, modern automobile engines are made to breathe in the dirty air they have already expelled. This function, known as EGR, exhaust gas recirculation, is used to meet strict emissions regulations and improve fuel efficiency. EGR was first introduced in the 1970s and was used to reduce the production of nitrogen compounds, toxic substances contained in exhaust gases. Yes, it was due to the so-called Muskie Act. If you'd like to learn more about the Muskie Act or emission control systems for gasoline engines, please watch the video titled, Emission Control Systems, Gasoline Engine, How They Work. You'll find a link in the description. Approximately 78% of the air drawn into an engine is nitrogen. Nitrogen is stable at room temperature. But when fuel combusts in the combustion chamber and the temperature rises, it reacts with oxygen to form nitrogen compounds. Nitrogen compounds are substances that contribute to photochemical smog and acid rain, and their emissions are strictly regulated under exhaust gas regulations. In the 1970s, EGR was the only method available to reduce nitrogen compound formation. This graph shows the relationship between the amount of nitrogen compound generation and the combustion temperature. Thermal NOx is formed when oxygen and nitrogen in the atmosphere combine under high temperatures. Fuel NOx is formed when the nitrogen in the fuel combines during combustion. Prompt NOx is formed when compounds of carbon in the fuel and nitrogen in the atmosphere combine with oxygen in the air during combustion. We can see that the amount of nitrogen compounds generated increases as the combustion temperature rises. Conversely, if the combustion temperature is lowered, the amount of nitrogen compounds generated can be reduced. A large amount of carbon dioxide is generated by the combustion of fuel. The purpose of EGR is to recirculate these carbon dioxide gases back into the combustion chamber. Compared to oxygen, carbon dioxide has a higher molecular weight, so it requires more heat to raise its temperature. In other words, when the same amount of energy is applied, carbon dioxide's temperature increases less than that of oxygen. As a result, the combustion temperature decreases, reducing the production of nitrogen compounds. At that time, fuel supply was controlled by a carburetor, and there was no method to precisely control the amount of recirculated gas. As a result, the recirculated gas caused unstable combustion. And to prevent this, it was necessary to use a richer fuel. This not only worsened fuel efficiency, but also led to an increase in hydrocarbons, which were restricted by emission regulations. In the 1980s, the widespread use of three-way catalysts in gasoline engines reduced the importance of EGR for reducing nitrogen compound generation. In modern gasoline engines, EGR is used not for NOx reduction, but for improving fuel efficiency. To understand this mechanism, we must first understand pumping losses. Pumping loss is the loss that occurs when air is drawn in through the intake pathway narrowed by the throttle valve. If you want to learn more about pumping loss, please watch the video, Engine Brake and Pumping Loss, How They Work. The link is in the description. The engine takes in the amount of oxygen required for combustion through the throttle valve. At low engine speeds, the amount of oxygen required is also small. So the throttle valve opening is narrow, resulting in significant pumping loss. If the throttle valve is open wider, the pumping loss can be reduced, but too much oxygen can cause unstable combustion. At this point, recirculating exhaust gases that do not contain oxygen can help reduce pumping loss. Generally, at 50% load, pumping loss in a gasoline engine is about 10%. Therefore, if this can be reduced, fuel efficiency can be significantly improved. There are two methods of EGR: internal EGR and external EGR. Internal EGR is a system that recirculates exhaust gas from the exhaust port during the intake stroke. For this, the exhaust valve must be opened during the intake stroke. Or in other words, the valve overlap must be increased. In older engines with fixed valve timing, a large valve overlap can cause issues such as unstable idling. Today, many engines are equipped with variable valve timing, allowing the valve overlap to be adjusted as needed to utilize internal EGR. This animation is an example of a variable valve timing system. Hydraulic pressure adjusts the phase between the camshaft sprocket and camshaft, allowing the valve timing to be varied. If you want to learn more about variable valve timing, check out the video, VTEC, Valvetronic, VVT, etc., how variable valvetrain systems work. There's a link in the description. External EGR system is a system that recirculates exhaust gases from the exhaust manifold to the intake manifold through a pipe installed outside the engine. An electronically controlled EGR valve is installed along the exhaust gas passage, and it opens and closes based on engine operating conditions to regulate the amount of recirculated exhaust gas. EGR valves come in types such as poppet valve and butterfly valve, and they open and close based on signals from the engine control unit. The EGR cooler is a heat exchanger installed along the exhaust gas passage, which lowers the exhaust gas temperature using engine coolant. Its purpose in a gasoline engine is to suppress knocking. Knocking is a type of abnormal combustion that occurs when the temperature inside the combustion chamber rises too high during the compression stroke, causing combustion to start in areas other than the spark plug. If exhaust gases at high temperatures are drawn into the combustion chamber, the temperature of the compressed air increases, making knocking more likely to occur. To prevent this, the EGR cooler lowers the exhaust gas temperature, which can reach 500 degrees Celsius to about 100 degrees Celsius. The purpose of the EGR in a diesel engine differs from that in a gasoline engine. Since diesel engines do not have a throttle valve, there is no pumping loss caused by the throttle valve, meaning EGR does not contribute to improved fuel efficiency. Additionally, because diesel engines lack a throttle valve, they intake large amounts of nitrogen and oxygen even at low engine speeds, resulting in the generation of significant amounts of nitrogen compounds. If you would like to learn more about diesel engine exhaust gas purification, please watch the video, Emission Control Systems, Diesel Engine, How They Work. The link is in the description. For these reasons, the EGR in diesel engines is used to reduce the generation of nitrogen compounds. The components of the EGR system, such as the EGR valve and EGR cooler, are similar to those in a gasoline engine. However, in diesel engines, which do not have spark plugs, the EGR cooler is used not to suppress knocking, but to improve the engine's volumetric efficiency. Also, diesel engines generally do not use variable valve timing mechanisms, because they operate within a narrow range of engine speeds. However, since an internal EGR function is necessary, some engines are equipped with a mechanism that opens the exhaust valve during the intake stroke. The intake and exhaust rocker arms are equipped with pushrods, integrated into the hydraulic circuit. During normal operation, the control valve is open, and the hydraulic circuit is released. Therefore, the movement of the pushrods does not influence hydraulic pressure. During internal EGR operation, the control valve closes the hydraulic circuit, causing the hydraulic pressure generated by the intake rocker arms pushrod to open the exhaust valve. EGR, which can reduce harmful substances in exhaust gases and improve fuel efficiency, also has its drawbacks, however. The biggest issue is the accumulation of sludge in the recirculated gas passage and the intake system. Exhaust gases contain soot, which is solidified hydrocarbons from unburned fuel, as well as engine oil. Over prolonged use, these substances accumulate in the EGR pipes, EGR valve, EGR cooler, intake ports, and intake valves, obstructing the gas flow and causing a decrease in performance. This phenomenon is particularly noticeable in diesel engines with a high amount of soot in the exhaust gases, and in hybrid vehicles that often operate in cold conditions. The introduction of EGR has improved issues with exhaust gases and fuel efficiency, but it has also brought about new problems that need to be addressed. The engineer's challenge continues endlessly. Thank you for watching. If you enjoyed this video, please consider subscribing to the channel. We'll see you in the next video.